would like to welcome everybody to the next edition of the FCHEA Circuits webinar. The title of this is Molecules in Motion, Hydrogen's Role in Moving the Maritime Sector. And I would like to personally introduce you. I'm Frank Wolak, President and CEO of FCHEA. FCHEA initiated this Circuits webinar series to offer timely and relevant topics to industry. The series is designed to offer deeper insight into specific topics than found in more general webinars. And today we are pleased to offer a discussion on hydrogen in the maritime sector. For those who don't know FCHEA, we are the industry trade association for hydrogen in the U.S., advocating for hydrogen and fuel cell technology for over 35 years, representing leading companies in production, distribution, and use, providing an industry voice, educating, and overall enabling organizations of all types to advance and achieve in this sector. Jen, next slide, please. You'll be presented today or have the opportunity to have presentations from a group of panelists, but I'd like to put a bit of context into this edition of Circuits. Hydrogen's value extends not just to direct use in applications. Hydrogen is a key feedstock in a variety of low-carbon fuels, including those seeing growth in the maritime sector. Similarly, hydrogen and fuel cell technologies are becoming integral parts of new systems deployed to support maritime innovation. As the leading advocate for hydrogen in the U.S. and with a lens toward global developments, FCHEA and our members seek to advance policies that support the importance of hydrogen in derivative fuels and in the use of hydrogen technologies. Today, we are really pleased to be presenting a panel that will describe applications of hydrogen and help you understand the connection of hydrogen to the broader world of maritime innovation. They will give you an overview of International Maritime Organization decarbonization targets, technical and infrastructure advancements, and challenges to deployment. And they'll explore various pathways that hydrogen and fuel cells are being integrated into maritime applications. For FCHEA members in attendance, this webinar will expand knowledge of the many topics we discuss regularly in our internal technical and commercial meetings and our communications. For those of you who are non-members, we hope this webinar will open some insight in areas of importance to your business. And anyone interested in membership, please contact us at fchea.org. And with that, I'd like to introduce Tim Urban, the Executive Director of the Marine Innovation Coalition, and he will introduce and guide the panel made up of key members from PowerCell Group, Chart Industries, and Nuvera Fuel Cells. Tim, I'll turn this over to you.
Thanks, Frank. So first of all, thanks very much for the invitation. I'm honored to participate. Very excited about hearing from the speakers as much as you and our people who RSVP'd. So my name is Tim Urban. I have two hats that I wear alternatively. I'm with Bracewell Law Firm, where I'm the firm's tax policy leader, but I'm also the executive director for the Maritime Innovation Coalition, which is a group of ship owners, ship builders, and fuel producers who are involved with advocating for clean fuel transition, both nationally and globally. So with that being said, Frank, I wanted to kind of start off the webinar with a few factoids just to sort of frame up what we're talking about here. So for many of you already know this, but global shipping consumes annually about 300 million tons of fossil fuel, which is approximately 5% of the world's annual oil supply. That fuel, when consumed, accounts for 3% currently of the total greenhouse gas emissions around the world. But by 2050, if led to its own devices, shipping emissions will increase as a percentage of total global greenhouse gas emissions to 17%. So, that's a big deal. Currently, the fuels that are the staple for global shipping include heavy fuel oil, marine gas oil, and liquefied natural gas. But I think, it's a pretty exciting time to be working in this area because now shippers are looking at a slate of fuels in different applications, including, biodiesel, bio-LNG, biomethanol, e-methanol, blue ammonia, and clean hydrogen. So, this all is part of a sort of a technology neutral approach to cleaning up the emissions from these global shipping activities. So to hear more from the panelists who I've taken a preview, a sneak look at their slides, and it's really kind of interesting and exciting stuff and very futuristic. So the first speaker will be Andreas Bodén, Senior VP and Chief Technology Officer from the PowerCell Group. The second speaker will be Mr. Martin Kalecky, the Product Manager, Marine Systems for Chart Industries. And our cleanup hitter will be Giampaolo, I'm sorry, Sibilia, the Director of EU Operations with Nuvera Fuel Cells. So, Frank, I think without further ado, if Mr. Bodén could start off, we'll hear from him and look at his slides first.
So, thank you, Tim, for the introduction. Glad to be on this seminar, calling in from Europe. So I'm gonna give you a little bit of our experience on the current ongoing projects and the one we have in pipeline regarding hydrogen and methanol as a hydrogen carrier. So next slide. So we are based in Sweden, but of course we have some operation. We have office now in US due to big movement seeing there. We originally are coming from Volvo Group and have our strategic partner with Bosch, so creating a strong alliance and a partnership with them. They're also the biggest shareholder. Can take the next slide. So today we have industrial products, which you will see for marine, aviation, and stationary. And maybe you saw in the LinkedIn that we got an order for fuel cells for data center this Tuesday. We have nice development facilities, and also we can produce enough megawatt for the current need of the industry. Next slide, Jennifer. So complementing our product offer, we do a lot of soft offers as well with consultation, support, and modification of standard products, especially in marine to fit the different fuels. Can take the next slide. So this is on the left-hand side, you can see DNV's a picture from DNV's report about future fuels with fuel oil, methane, methanol, ammonia, and hydrogen. Of course, we need, as of today, have a buffet of them, and from a fuel cell perspective, of course, different technologies fits different fuels. On the right-hand side, you can see a number of projects PowerCell have, the different colors on the bars, and the dots are how many megawatt we got in order in marine industry the different years. As you can see, we touched compressed liquid hydrogen, we doing methanol, we also have done ammonia. So next slide, please. And we can see where it's happening currently. It's more on the inland side, the bulk carriers, the short sea shipping. On deep sea shipping, it's still just for smaller APUs where we see the interest. But on bulk carrier and short sea shipping and ferries, we already have projects, as you will see. And we see the different fuels, hydrogen and methanol and ammonia for the different types. Hydrogen and methanol more for the coastal shipping, and ammonia seems to be more the case for deep sea shipping. And if you have point to point, like ferries, hydrogen seems to be a little bit favorable as well as short sea shipping. But when you have vessels that don't go from point to point, going different ports, methanol seems to be favorable for those operators. Can take the next one, Jennifer. So this is our hydrogen system. We also use that for other fuels as well with some small adaptation. So this is our third generation marine fuel cells. So of course we learned a lot from generation 1 and 2. So we have already shipped around 150 of these units over the last 12 months. It has type approval from Lloyd's, RENA, and shortly we will also have DNV. It's a 225 kilowatt net system with good efficiency. And if you look on, we take the next slide, Jennifer. You can see that it's done with modules. So it's very appreciated by the customer where we can ship the cabinet early and then slide in the modules later to have a clean installation and clean commissioning. And also very easy service procedure with sliding in and out this module. Next slide, Jennifer. So our breakthrough project was the breakthrough ship done by Fedship in Europe. It's a 0.2 megawatt fuel cell installation run by liquid hydrogen. So in this project, we had to adapt our fuel cell for lower pressure operation, which was good. And it's quite nice. It's undergoing sea trials and are in operation. We can take the next picture. And then the current big project that we have delivered the fuel cell and now being installed and gonna commission is 2 ferries in north of Norway. That's gonna be operated for 15 years. So not just supplying the fuel cell, we're also supplying a service contract for 15 years to maintain the operation of the fuel cell installed in this vessel. So they are really going to commercial operation now, the fuel cells, and the hydrogen is the main propulsion source for these 2 ferries. Next slide, please. And also we have supplied a little more than 13 megawatts of fuel cell to Isotta, which is a daughter company of Fincantieri, to run on cruise ships for secondary propulsion. And also here is the liquid hydrogen that is the source of the hydrogen. For the ferries on the last slide is compressed hydrogen. Then we going over to the methanol part. Let's see this as a hydrogen carrier. If it comes from e-methanol or biomethanol, it's a hydrogen carrier. It makes the bunkering slightly easier because it's a liquid. Of course, we lose a little bit of efficiency due to the cracking of the methanol into hydrogen. But for some vessels, this is preferred, especially for vessels that is having dual fuel engine for diesel and methanol today. This product comes in neat as a secondary propulsion and APU unit. The reformer is supplied by E1 Marine, the US company, and PowerCell then taking our low pressure adapted fuel cells to be able to run on the low pressure from the reformer. So this is a 250 kilowatt net power output. We have AIP from DNV and RENA. And now it makes it easy for the customer to integrate. They don't need to worry about operating a reformer. They don't need to worry about operating fuel cells. We take care of everything of that. And then we're also recycling the exhaust water from the cathode side to mix with pure methanol to be able to carry more fuel on board. You can take the next slide, Jennifer. So we already, as you know, working on the Hydrogen 1 project down in New Orleans with Maritime Partner. It's a 2 megawatt thing. In this one, they're not using the M2 power solution. They are using an array of reformers and fuel cell, but the principle is the same. And it's going to be the main propulsion source. We take the next slide. And then in Europe, we are retrofitting a yacht where the two of these methanol systems gonna be the primary propulsion of the vessel when it's not sailing. So it's gonna be delivered next year to them. So it's a very nice project doing a retrofit of a very nice ship here. And then we have the last project in our methanol portfolio on the next slide, Jennifer. So here it's a 2 megawatt installation using this unit with 8 units and full integration methanol power solution. So it's used for secondary propulsion and APU for a total. And then, of course, they have dual fuel engine as their main propulsion. But it's contributing to a significant part of the power for this vessel. So next slide, please. So compared to diesel, we're reducing CO2 emissions, we're reducing particles, NOx, etc. And there is a white paper from E1 Marine, which we want to read a little bit more about this. We can go to the next slide, Jennifer. I think a little bit of the learnings and a little what I want to share. The system integrator is key because it's a lot of new things when you integrate fuel cells with batteries and hydrogen storage and methanol storage. So the integrator needs to be very proactive, and you need, as a supplier, really work across the boundaries. Even though every ship is unique, the technology doesn't need to be. That's why we have a standardized product that we work with on the different projects. And of course, safety comes first. And we need to be practical, not just theoretical. And we learned a lot, and we're sharing that knowledge with class societies and the integrator, how to integrate the fuel cell in a very safe way. And then, of course, every ship is unique, but we need to carry over the knowledge, both as suppliers and integrators as class society. So we can take the next slide. And then, of course, we're looking forward. As you know, if we don't do 100 kilowatts, it's difficult to do a megawatt. And if we don't do megawatts, it's difficult to do 10 megawatt. So the current projects, as you see, we're working up is to up to 6, 7 megawatts. But then, of course, we're also looking into the future to be able to propel even larger vessels. So we are currently developing a 300 kilowatt stack block, where we can take 3 or 4 of them to do a megawatt fuel cell system to be able to propel even larger ship in the future. So last slide, I think we have. So PowerCell is the leading fuel cell provider on the PEM fuel cell type in the world currently, with type approved system and serial production. We can do different hydrogen carriers, and our experience that collaboration is the only way to be successful on this first of a kind installation. But we already have the next generation in develop to be able to go for larger ship and lower the cost even further. So thank you for having me here to present.
Andreas, this is Tim. Thank you very much for taking us through your slide deck. I thought it was very exciting. One thing I noticed, I think we'll probably have questions and answers at the end, but one thing I noticed is that, you know, there's not like one silver bullet technology solution for every sort of business and, you know, fact case, but that manufacturers, you know, like your company are sort of responding with different creative solutions that are tailored to different, you know, needs.
You're correct, Tim. You know, but the good, you know, if you look on the system that we use for hydrogen, compressed liquid, reformed methanol, reformed ammonia, 98% of the system is the same. So we can use the same serial produced product, and then we just do small adaptation either in hardware or software to fit the different solution. I think this is the key. So you don't need to innovate the new product just because you're switching fuel. Because then we, as we have done for the fuel cell industry for 20 years, we just continue developing rather than getting the deployment experience, which is more crucial now.
Okay, so thanks again very much. And I'm guessing you'll probably be asked a few questions at the end. If it's okay, I'd like to turn to Mr. Martin Kalecky with Chart Industries, who has another slide deck, and we're all ready to go, sir.
Thank you very much, Tim, and thank you, Andreas, for setting up the stage. So now we heard about the fuel cells, and I actually want to today focus on what is upstream of the fuel cells and everything what needs to happen before that, and how we can get the molecule to the fuel cells. So if you don't know Chart Industries, quick introduction. We are a global company based in United States, but spread across the globe in 64 manufacturing sites globally. I'm sitting in Czech Republic, heart of Europe. We have more than 11,000 global team members, and combined we have 165 years of engineer cryogenics competency and experience. We are a global leader in many verticals, but if I will keep aside LNG, air gases, water, and so on, and focusing purely on hydrogen, we built over 900 large volume liquid hydrogen tanks, which accounts for 90% of the global liquid hydrogen tanks fleet. What is unique about Chart is that we provide every single component in liquid hydrogen value chain. It comes from liquefaction systems, transport, bunkering, and propulsion. We are not owner or seller of the molecules. Those are our customers. We provide the systems, the steel which stores and moves the molecules. We are in a very unique situation where we are kind of an intermediate between the fuel producers and fuel off-takers. So we are able to interconnect both parties with the technology which is already existing. If we can go to the next slide, here are a couple of our projects that we are working on and we finalized in the past. I will not go through all of them, but I will be speaking today about examples of our liquid hydrogen swappable tanks, which belongs to the ocean cruisers, and also about the liquid hydrogen container vessels. In past, we also deployed a lot of LNG systems like the fastest ferry, which operates in South America, or LNG fleet of fish feeders in Norway. And what is, for example, very interesting for American audience, it is the last picture of the largest cryogenic tanks ever made. These are 1,700 cubic meters, double-walled vacuum insulated tanks, which are built in near Mobile, Alabama, in south of United States. And this is the facility where we produce the largest cryogenic tanks. So if we go to the specific projects, this is the most important project that we are or have in Europe. It is some skip sea shuttles, container vessels. These are two 135 meters long vessels dedicated for the Rotterdam-Oslo shipping road. They are equipped with 3.2 megawatts fuel cells, and they will be running purely on hydrogen. It is estimated they will avoid 25,000 tons of CO2 per year. Our scope is to deliver a complete liquid hydrogen fuel gas supply system, including two of 215 cubic meter Type C double-walled liquid hydrogen tanks, and the complete system for the hydrogen delivery. What is interesting about this one is that each vessel will carry 17.8 tons liquid hydrogen on board, which is the world's first for maritime used as a fuel. If we go into more details about this system on the next slide, this is the classic architecture of the fixed tank solution that we deploy on board of the ship. I will not go into the details, but as an essential three steps, we need to have a storage of the molecules, we need to convert it, and we need to deliver it to the fuel cells. So we have two tanks here with capability to store liquid hydrogen at the 5 bars with minus 253 degrees Celsius, and tank connection space, which is housing all the handling equipment and heat exchanger responsible for safe evaporation of the fuel to the gaseous state and delivery to the fuel cells at the given flow rate, pressure, and temperature. All the system is automated with the gas control and safety system, so the operation is safe and reliable. If we have a look on the next project, which is with the same purpose but completely different architecture. We are talking about two ocean cruisers for Viking ocean cruises and European Union supported SHIPES program, Sustainable Hydrogen Propulsed Shipping, which is the first swappable liquid hydrogen storage on a cruise vessel. We are developing two hydrogen containers per ship, which has a 45 feet frame, and they carry 2.2 tons of usable liquid hydrogen tank. And the ships are equipped with 6 megawatt fuel cells. Why this matters? In Norway, there is a set target for entering the World Heritage Norwegian fjords with zero or low emission vessels. Originally, it was from 2026. Now it's pushed beyond to 2030. But the goal of the owner stays the same. So we are developing this partial solution when these ships can run on hydrogen for a limited period of time. So for entering those fjords for a couple of hours, or using it as an auxiliary system for hotel load when ship is docked at the port. What is unique about this system is that we have a complete swappable system, and we completely eliminate bunkering system. So there is no need for bunkering of these vessels. We simply bring the full container of liquid hydrogen to port and load it on board of the ship. If we have a look on details of this project on the next slide, you can see each ship is equipped of two swappable containers, and their dedicated tank connection space, again, which holds all the necessary equipment for delivery of the molecules. Again, I will not go into the details. Maybe we can, if there will be questions about this system, we can go into the more details. What is unique about this one is that one part of the system stays inside of the ship and it's fixed to the deck. And the container is brought on board of the ship, and it's connected with flexible hoses and quick disconnection couplings. If we go to the next slide, so far we've seen only renderings, but I can assure you this is happening right now. So this project is currently past the testing phase with liquid nitrogen, and first liquid hydrogen fill was achieved. And actually today we started with the liquid hydrogen testing in our Italy facility for testing purposes. This is part of the European Union project, and we are obliged to test it like this. And at the same time, we are installing our equipment also on board of these ships in Italy. So you can see these liquid hydrogen ocean cruises are built, and our equipment is already in installation and commissioning phase. And soon these two ocean cruisers will be sailing next year. I will conclude with the last slide, where we have 3 lessons from Europe's front line about hydrogen. So from our point of view, the regulation is catching up and not blocking the progress. So net zero framework, which was approved in last year, the adoption was postponed, as we know, but the earliest entry into force is 1st March 2028. So we eagerly look at the October meeting, what will happen, and if we can go forward. Nevertheless, there are different sets of regulations in Europe which pushing the innovation in these technologies forward. So even class societies and all necessary stakeholders like shipyards are getting seriously ready. Second point is that IGF code has no liquid hydrogen chapter yet. So all projects use alternative design. So every hydrogen ships that today runs or will be running on hydrogen needs to go through alternative design with dedicated HAZITs, HAZOPs, and studies to get the approval in principle from classification societies. So the tool exists, and early class engagement is the key for these projects. Last point is that short sea, as Andreas mentioned, is the first one, and deep sea will probably come a bit later than the short sea. All the initial liquid hydrogen projects are on a fixed road with the predictable refueling, mainly Norwegian ferries, passenger vessels, fjord cruisers, or short container routes. That's exactly where we see a lot of activity, and this is our pipeline of the projects. Three takeaways for North America. Liquid hydrogen hardware exists today, and this hardware is class certified and built at shipyards. Marine industry will be the biggest adopter of liquid hydrogen, and the demand will rapidly increase after 2030s. So it is very good to start planning now. And the last one is that Chart is here to be your cryogenic partner from the liquefier to the fuel cell inlet. Thank you very much.
So, Martin, this is Tim. Thanks very much for the presentation and the slide deck. It really struck me looking at this that the transition to clean maritime fuels involves not only ship engines and not only ships per se, but there's an entire ecosystem that's involved in producing the fuel, getting the fuel to a harbor, getting the fuel onto the ship. And that, I know here in the United States, a number of our ports are involved in sort of proof of concept experiments with the US government to, have limited adoption of various clean fuels just to show how it would work and what's required. Most people forget that here in the United States, it took us like 100 years to adjust all our infrastructure and governmental rules and incentives to fully, adopt fossil fuels. And so it's going to take a little while of getting all of that infrastructure and bunkering and pipelines and whatnot all implemented internationally as well. I think your presentation was excellent, and I really appreciate it. If I can, I'd like to move over now to Mr. Giampaolo Sibilia, who's the director of EU operations for Nuvera fuel cells, and we are ready for your presentation, sir.
Thank you. Good afternoon and good morning to everybody. Calling from Europe as well, so Italy specifically. And I'm going to talk to you about what we are doing in FCHEA, which is our company. So next slide. So FCHEA is a global company, mainly active in material handling industry, with some other activity, including let's say energy solution, where we have our fuel cell that are traded under Nuvera brand. Then there are other Ister and Yale, the two main brands for lift truck, and other let's say companies like Bolzoni for attachments. So it's as I said, it's a global company across all the continents, more than 8,000 employees, and our focus is to basically help the customer to move the goods in every way is needed, without let's say never letting the customer down. So in the frame of the material handling, of course, the energy is needed, is required to do to power the lift truck. So here is where Nuvera is coming to play, and then from that things expands also to other let's say application like maritime and so on. So next slide, please. So here is our let's say main products that we call fuel cell engine. Is a fuel cell system which includes the stack plus some balance of plant component that are needed to ease the integration in the application. We have mainly one family that is called the Nuvera E series. Here is displayed the E60. We have even the E45. There's a different in power. And then our new launch is the 125 kilowatt. Is a new stack and let's say almost double the efficiency with a little increase in size, but it's not double the size of E60. Next slide. So here are some solutions. As I mentioned, the FCHEA is focused on material handling, but our fuel cell has been used in various applications. Here we have the application. We have some more slides after that are more linked to maritime. So you see on the right some boats that where we supplied our fuel cell to partners which are integrating excuse me in the boat. As I said, the engines are designed in a way that to ease the integration, to simplify the life. You don't need to be a fuel cell expert to operate that thing, but it's enough to connect to a cooling system and to provide the hydrogen basically and the control. Next slide. Here is our view on the usage, for example, of the fuel cell. So it's clear there are different requirements in power. The larger the size of the ship, the larger the power is required. The fuel cell is scalable itself, but the system needs to be designed. So we see a different usage of fuel cell, and specifically also differences in hydrogen source. Here I added to what has been said, compressed liquid and so on. For example, in the installation that we did in that boat that I show, the hydrogen is stored in metal hydrides because the customer was, let's say, particularly focused on that technology. In addition, we are Nuvera, we are participating to some EU-funded project to use the hydrogen coming from ammonia, because ammonia, as I already said, is one of the possible fuel for the big ships. Next. Here is an example. The boat I was mentioning before. There is one engine of 45 kilowatt. Hydrogen is stored in metal hydrides and is currently waiting the certification to start sailing. Next slide. This is the product of our main product of our company, are port equipment. It's a reach stacker, so basically needed to load and unload the ships, so you can easily move container. There are engines in the boat, fuel cell engine, fuel cell tanks. The hydrogen is stored in compressed form, 350 bar. And this has been used in those two ports. And now we have, let's say, orders for other 3 or 4 ports in Europe for those kind of equipments that are manufactured out in our facilities in the Netherlands. Next slide. And this is our latest product that it is for sale in the US only. It's a power generator that can be used, of course, in ports. That includes a fuel cell, a hydrogen tank, and can be used either as a genset or to recharge electric vehicles. And this is specifically good in case you have a temporary need or there is no possibility to have a connection to the public grid. Next. So as I said, what we say for the maritime, our solution is our fuel cell engine. Where Nuvera really wants to play today on port equipment, because it's our main, let's say, main business. Reach stacker, empty container handler, terminal tractors as well. Next, we want to expand also taking advantage of our experience with this boat to small boats and so on, and future scale maritime propulsion also thanks to our, let's say, project with the ammonia. Next. So this is the last slide. So what we want to say that the context is complex and there are multiple application and power level and uses. We have one size cannot fit all, but we want to start, as I said, with the port equipment and then to transition to, let's say, boats starting from small to the large one. And of course, with the need of certification for the maritime. I think that was the last slide. So thank you very much for listening to my presentation, and thank you.
So thanks very much. I found that super interesting and informative. One thing that sort of jumps out at me as I look at all 3 slide decks is that there's a sort of an analogy here between maritime fuels and sustainable aviation fuels used in airlines. And that is that there's sort of an international technology. You're going to need to have ports and bunkering, not just in one country or one union, but around the world for something like this to really work comprehensively. And so I think it sounds like there's a role for sort of international rules and maybe even international incentives and mandates to try to keep everything, being developed concurrently and make sure that the size of the pipes and the valves and the facilities at the ports are all sort of match up so that a ship can dock anywhere in the world and find fuel and find a fitting that fits on their fuel tank or whatever. So I want to say, first of all, on behalf of FCHEA, thanks very much to all three panelists. I know that there are probably a number of questions among the audience members, so we'd like to try to field a few of those if we can in the remaining time. Jennifer or Connor, are you prepared to enunciate the questions that come in?
Sure, Tim, I'll handle that, Tim. I want to thank everybody. This has been really enlightening for me to hear what our members have to say that I don't always get a chance to hear in our various meetings. We have some questions up on the screen. I think if anyone else has any that are burning, start kind of typing them in and I'll sort of field them. Many of these are very technical, so I'm going to try to look at the ones that are a little bit more broadly. We have a question here about certification, and if it hasn't been covered, what organizations are certifying various products? Is it a vessel certification, or is it fuel cell systems, or a system certification? Perhaps if the panelists can talk about the subject of certification of your various technologies and give our audience a sense of who's involved in the background.
So let me start there then. So for the fuel cell systems, there is class rules already available. So that's why you can type approved systems. And currently, we know that DNV, Lloyd's Register, ABS, RENA, US Coast Guard are working on this. So there is type approval systems available, just not from PowerCell, but also other companies. When it comes to reformer, they have the same issue as the liquid hydrogen storage. There is no class rules except for alternative design approach, the risk-based assessment way. So for vessels that currently using the reformers, they need to go through a ship-specific approval.
Any other input from our panelists on that?
Yeah, I would echo what Andreas mentioned for the cryogenic systems. Indeed, as I mentioned, we need to go through alternative study design and risk-based certification. When it comes to all the components that are, let's say, dedicated for liquid hydrogen, we need to go for the special evaluation with the class societies to prove the use with the liquid hydrogen. And the hurdle is sometimes the tests are not feasible to do with these first kind of products like valves to test it with liquid hydrogen. So they need to be tested with liquid nitrogen, which is higher temperature. And then we need to justify it to the class society that we perform the tests with liquid nitrogen only, and these are then certified with the class society, put into the system, and then verified with the liquid hydrogen in the operation.
And for Nuvera, basically, Patrick again, what already the other two panelists said. So we are, let's say, for our fuel cell, they are all coming with a certification of incorporation for the CE mark, and in addition, depending on the application, there are specific standards to be followed. For example, for big truck, lift truck, there is a specific requirement for that. That deals, for example, stricter rules for insulation resistance. But so there is let's say, a common certification for the fuel cell system and a specific one depending for the application for us.
Interesting. There's sort of a follow-on question to this. There is a question that came up, but I also have a question that's near and dear to my heart, since FCHEA helps to manage the inventory of codes and standards in the for hydrogen and fuel cell technologies for the U.S. government. Question is, are there current what initiatives are currently undertaken in developing and establishing applicable codes and standards for hydrogen in the maritime sector? And maybe more importantly, are there any gaps? Are there some things that need to be addressed by the various codes and standards bodies that are impediments to the growth of hydrogen related technologies? Any sense of that?
I think, as Tim mentioned, since this gonna be global, as you know, aviation and marine is global and not so local, I think harmonizing the standards through IMO is beneficial for the whole industry, since these vessels might end up somewhere else in the world than Europe and US. And also that class societies and countries' approval bodies also adapt to these rules rather than trying to invent their own. I know that, for example, in Japan, there is different rules when it comes to hydrogen safety for different pressures. This is a typical hurdle that would make introduction of fuel cells difficult in that region, rather than, for example. So I think harmonizing across the globe is key thing here.
Good. I see a question here, and I'm going to maybe turn this to Martin for a first opening. Uh, we have a participant on the call who is delighted to see liquid hydrogen being deployed, even if it's still gray. But the question is really, about port infrastructure. How many ports have sort of storage? Are there plans to have this in the coming years? Maybe give a sense of what you see for the storage growth in the various infrastructure investments.
Right now, I don't see any, to be honest. Not in Europe right now. There are some in Japan, in Australia, that famous Swiss Frontier cargo vessel. There are ports to be able to store liquid hydrogen. Europe is still planning, and that's actually the biggest challenge everywhere in the world. Because when you think about hydrogen ship, it is immense challenge, but it's nothing to compare to the infrastructure to be built. Ports are educating themselves about various fuels and what it takes to have that fueling capacity, bunkering capacity, storing capacity. Currently, how it's done is that everything is movable. So, for example, bunkering system is mobile system that can be brought to the port, to the quayside. And then there is a trailer coming to the port at a dedicated safety area with all the hazardous zone. And for example, liquid hydrogen ferry is then filled with this setup. So there is still no port with fixed equipment that would be used periodically. There are only plans for mobile, which is kind of a transition period from that we will demonstrate this technology and we will go forward to the larger scale fueling.
I have an obvious question that came up, and it's something that's probably near and dear to many people on this call. But China is advancing many hydrogen technologies. It has its own activities in the maritime space. What is China doing in this sector? And can you give us a sense of what you see on the horizon from the vantage point of China?
Still a question for me?
And for anybody, and including Tim.
Okay. From my point of view, very quickly, I would see the most activity is first of Europe, mainly Norway, and then Netherlands, and then also in Asia, Japan. China, I don't have that much visibility that liquid hydrogen would be developed, so I would leave it to my colleagues if they have a different overlook there.
If you look on the 5-year plan, the focus is on the on-road transportation when it comes to hydrogen and fuel cells. They have a few demonstrators on inland ships, the barge type. But as we know, a lot of marine ships are built in China, so of course they will catch up. They have now the largest fleet for trucks, for example, and we know that they are quick, so they will catch up with us. But I agree with you here, Martin, that Europe is leading the maritime part, US is following, and then Japan, and let's see. Korea is trying to catch up as well.
I have a sort of a question here, maybe a bit more on applications and technology and the world at sea. Maritime environments are very difficult environments to operate any type of equipment, any type of machinery in. You've got salt, you've got water. As you're introducing these technologies into the maritime space, how are you addressing the traditional maritime environment with salt, water? How are your technologies being designed to be durable and reliable in a very harsh environment?
So when it comes to development, especially on the fuel cell side, there is type tests. So to be able to get the type approval sticker, you need to do salt spray, you need to do the tilt testing, shock vibration, that we can manage. Then, of course, I saw in the question list that filtering out the salt mist and particle is key. So in all the vessels that we are involved in, there is a three-stage air filtration to get all that stuff out of the air before it enters the fuel cell.
Yeah. We are coming up to the last 5 minutes, and I'm going to go back to Tim here. Tim, are there any particular questions that we can go back to the audience questions, but are there any particular topics that you feel we should raise among the panelists with our own set of questions?
So thanks, Frank. I just guess from the U.S. perspective, the Maritime Innovation Coalition focuses on four sort of legs of the stool, and this applies mostly to the United States. But two of the legs of the stool have to do with the economics of the fuel, because to get widespread adoption, you can't have clean fuels be much more expensive than the other fuels unless there's a mandate. And so in the U.S., we have proposed tax incentives and non-tax environmental incentives like the Renewable Fuel Standard. And I guess my question would be: is it similar in the EU and around the world that there are various, both sticks and carrots being considered to lead ship owners and operators to adopt clean fuels?
Yeah, we see in you. I only can speak for Europe in this part, but there is we have the ETS system, emission tax credit system, that is of course now the coming 2-3 years not so hard for the operators, but it's progressing. So over the year, I think at 2030, if you still are emitting stuff, it's gonna cost you a lot. So they have time to start to change, which is fair. But of course, building ships takes some time. So if they don't start today, they will be hit by this, penalty. But then, of course, we also have the carrot coming from different EU programs to, develop the ship, do the demonstrator, build the infrastructures. And this ETS system, they are both the European version, but there is also a lot of local version. And there is another 40 countries outside Europe that has their own version of it. So we see this, carrot and, stuff moving along in different areas. But you're right, it cannot be too expensive. It can be slightly more expensive, but too expensive won't make it fly. So.
Along those lines, as the head of the U.S. Trade Association, we are always looking for good ideas to bring to U.S. policymakers. As you look around the globe at your business applications, market penetration, and areas of opportunity, are there any examples of policy activities, or going back to this carrot comment, are there anything that you see around the world that's really working and interesting that an audience in the US should hear about?
Yeah, from my perspective, from the frameworks of EU Maritime and also proposed I'm on a net zero framework, a pooling option through the fleet is very interesting, because when you have, for example, fleet of 30, 40 ships, and most of them still stays with the conventional fuels, and you convert at least one, to the pure hydrogen, zero emission, it can pool your emissions for entire fleet for next couple of years, which can save significant amount of money that comes from the penalties of these frameworks. So I believe this one works because we work with our customers, and I hear that this is the most, let's say, motivating factor for them to try and go with these first reference vessels, because it can help for them for the whole fleet which they own.
Interesting. Well, we are coming near close to the end here, and I'd like to comment that, while much of what our panelists have described have been outside of the U.S., clearly hydrogen is just in a global market, and maritime activities are those activities that connect goods and services globally, whether it's in ports or actually shipboard. There is a U.S. context of this, and I'll say it's sort of twofold. First, FCHEA members and many participants in the U.S. are multinational. They have manufacturing and technology base in the U.S., and the U.S. is a key participant in the production of fuels and a provider of technologies that serve maritime innovation. There is a connectivity no matter where you are in the maritime chain. But I think secondly, the world, you heard from all of our panelists that the world is moving to adopt lower carbon, cleaner fuels, specifically in the maritime sector. Tim opened up with some very important statistics about the 5% volume of fuels consumed in the maritime sector. And the policymakers in the U.S. need to be keenly aware that the positive impacts of pro-hydrogen policies are really important, but also there are negative competitive consequences from a lack of forward policies. And we want to make sure that we are keeping abreast of the best ideas and ways in which the U.S. can thrive and compete in this growing world. If your organization wants to hear more about what FCHEA is doing in general or doing to expand U.S. hydrogen opportunities in maritime areas, please reach out to us. I want to thank our panelists, Tim, Andreas, Martin, and Giampaolo, for the insightful conversations, and look to invite you to the next edition of our Circuits webinar, and stay posted for that on LinkedIn and on our websites. And again, feel free to reach out to FCHEA with any questions about subjects that are important to you. Thank you very much for everybody.
Thank you very much. Have a nice day.
Thank you.